based on last week's investigation into Nvidia's driver overhead on modern GPUs, are GPU reviewers testing GPUs wrong? What situations are we going to see this and what hardware configurations? We're going to talk about that today. Monitor Steve is here, so let's get into it. Welcome back to Hardware Unboxed. It's time for another Monitor Steve discussion. So over here we've got Monitor Steve, and you'll be very thankful that I've decided not to use one of our precious RTX 3070s. Not that there was actually an RTX 3070 in the box, but different box. We've got an MSI Z490 motherboard box here, so a non-controversial, a neutral box. You can buy these, pretty sure you can buy these if you really wanted one. Not sure why you would, but no box controversy on this video. But how are you doing, Steve? How's the testing been going the last couple of days?
Well, firstly, I'd like to say that it's very optimistic of you to think that there will be no controversy regarding the box choice. I'm sure the viewers will come up with something for you. But how I've been doing, been going well. Lots and lots of testing. It's actually ramped back up pretty quickly since getting back from a holiday. So obviously we've got new Radeon GPU on the horizon. We've got some Intel CPUs coming up. And then we've stumbled upon the testing that I'm currently spending a lot of time on. So heap of things there. It never ends, but it's all good fun. So, happy for it. Happy to be busy, I guess.
Yeah, so I think in today's sort of, I don't know what you'd call this series, a discussion series. It's been a bit of fun to get on these and do some of this in the past couple of weeks. But we do want to talk more about the Nvidia driver overhead video. First of all, I guess it's worth mentioning that there will be more testing coming up in the next couple of weeks. So there will be more benchmark graphs, more investigations to go through. But in this video, we just want to talk about some of the initial findings. I think we've got a number of topics we want to get through, like, are we testing CPU or are we testing GPUs incorrectly? Why are we seeing this? Where are we seeing this? Why are we testing DirectX 12? All those sorts of things. So these are just, it's not really like a Q&A type series, but just based on the feedback that you guys have given us in the comments, and also in places like Reddit, where there was pretty vibrant sort of discussion, I'd have to say. Probably a bit more positive than I was expecting for places like Reddit, where I was expecting, maybe AMD versus Nvidia, usual discussion here. But I think it's been, the feedback's been quite good, and it's good to see people interested in this sort of topic.
Yeah, definitely. I think it's gone over better than I expected, because it is, in some ways, some of the results quite radical, kind of hard to believe. It certainly was for me, even though I kind of knew what was going on and we'd sort of seen this before. But yeah, some of the results were quite extreme. Situations where a 5600 XT was beating an RTX 3090, that certainly cause for concern. A bit of a stop there and scratch your head and think, what the hell is going on here? I know I did a bit of that when I was seeing the results. And again, that's kind of what led us into this. Like, a few people were thinking that this is us going after Nvidia and trying to get them for the whole thing we had late last year. But of course, completely unrelated to that, I was doing some CPU testing, wasn't looking for this driver overhead issue at all. And you guys saw that video when I was testing a range of Ryzen 5 processors, all 6-core, 12-threaded processors, but the CPU performance overall varied quite significantly from the 1600X all the way up to the 5600X. And when we were more CPU limited, so the CPU was being maxed out because it had less overall CPU performance, we were starting to see this weird situation where the low-end Ryzen 5 parts were performing noticeably better with a Radeon GPU. And in that video, I explained that I believed that to be a driver overhead issue, down to the way that the GeForce driver handles. Well, it's a software scheduler, basically, whereas the Radeon GPU is a hardware scheduler that creates CPU overhead issues on the GeForce side. So anyway, we sort of knew what was going on there, but it wasn't very clear. It wasn't as clear as it could be from the range of CPUs and GPUs that I was testing. So I went back, spent a lot of time over the next 2 weeks. Obviously, I didn't dedicate every minute of every day for 2 weeks testing that, because we had other content we had to do. But let's just say a big portion of my 2 weeks was spent running all those tests. And yeah, the results in the end were obviously very interesting because it's made a bit of noise. So
Yeah.
I guess from that, there's been some commonly asked questions or even some sort of common misconceptions pop up around this. So I thought it'd be best to address those. Some of them are just opinions, but I thought, best that we address that stuff first and then explain a bit more about what's going on, at least what we believe is going on.
Yep.
So
sense.
I think one of the more common things we saw were people questioning how reviewers, such as ourselves, go about testing your more entry-level to mid-range GPUs. And of course, the whole which CPU should you use argument has been around for many, many years. So it's not like this video created that situation where people were questioning what CPUs reviewers should be using. But basically, I think to simplify this whole point, reviewers go about testing GPUs with a flagship, so a high-end CPU, to remove or at least reduce the CPU bottleneck in certain gaming scenarios. So that allows you to test the maximum or very near the maximum performance the GPU can deliver, and you can compare GPU performance with another GPU. So it's a GPU comparison.
Yep.
And that's obviously very useful when you're doing a GPU or graphics card review. And that's why we do things that way, even for lower-end GPUs. It also means you can compare low-end GPU performance to the high-end GPU performance because it's all apples to apples. It's across the same system. There's no some other limitation there that is limiting the GPU's performance. So it's kind of nice in that sense. And you might think, well, why do I care what performance an RTX 2060 does compared to an RTX 3080, because they're completely different price ranges, and that's fair. But you may be in a situation where you're thinking of throwing a bit more money at your next upgrade, and how much extra performance does that really net you? Is it worth it or not? So it's good to have all of that data. Now, the common argument has been, well, I'm not going to have a Core i9 10900K or a high-end Ryzen 9 processor almost ever. I usually buy like a Ryzen 5 or a Ryzen 3 or a Core i3, and I'm more of a budget builder. That's why I'm interested in buying a budget GPU. So I want to know, what differences are there when using sort of my realistic combo? And it is a very valid point to make, and we have gone back and redone in the past low-end to mid-range GPU reviews with a select range of games and a select range of hardware to have a look at that. And generally, there hasn't been too much difference in, I would say, the conclusion, the recommendations that we make. Generally, it's pretty much the same. But obviously, what we found here could change that depending on the settings and the conditions. And again, if we were to say take a range of mid-range to low-end Radeon and GeForce GPUs and test them on a low-end CPU, we may not necessarily see what we saw in that video if we test at 1080p to 1440p using ultra quality settings. It'll definitely make a small difference, but where we were really seeing the big changes were when people didn't want 60 FPS. They wanted to go 100, 120, 140 FPS. And to do that on low-end to mid-range hardware, you're not using the ultra quality settings. You're dropping down somewhere more towards medium, especially in games like Cyberpunk 2077, for example, which I have been testing for this upcoming video Tim spoke of earlier, which I'm hoping will be on the channel in about a week and a half, 2 weeks. And that saw the same sort of behavior as what we saw in Watch Dogs Legion. So spoiler alert there. So the point is, when using those ultra quality settings, you are usually targeting lower frame rates, and therefore it becomes a bit more GPU limited, or in some instances a lot more GPU limited than it would be CPU limited. So it's almost like you have to change the test methods entirely. So it's not just about using a low-end CPU. That is a crucial component for this type of testing, but you also need to be aiming for higher frame rates. Now, some games, it may not make sense to go for 140 for whatever it is FPS on a low-end hardware, but where it does for games like Rainbow Six Siege, for example, you really want to be using those medium quality settings. So it's not just different hardware, it's also different quality settings that you'd be wanting to test at as well. So to come full circle, I think the way reviewers test right now is the correct way. I don't think it is incorrect. I think really for testing GPUs, you should be using a high-end CPU and testing as we do. But Of course, it doesn't tell you the full story, at least not always. But doing what we just suggested, then it becomes more of, I don't know if would you agree, Tim, a system benchmark. It's not an exclusive GPU type review.
I mean, the way that I sort of looking at it and going back on your discussion and listening to it just then is that I guess there's kind of the two ways of benchmarking, isn't there? It's like you're trying to benchmark and remove all bottlenecks. So this is why, for example, you as well would be using, let's say, 32 gigabytes of dual rank, dual channel, low latency memory, which again is probably not something that someone building let's say a Ryzen 3 or Core i3 system is using. So when you're trying to remove all those bottlenecks, you want to remove all of them. So this is why you're testing in the way that you're testing. But then the other way to test is sort of the realistic conditions testing, which again, for a high-end system, is going to be virtually the same because you would expect an RTX 3090 to be paired with Core i9 processors, low latency memory, etc. But then for these mid-range systems, I totally agree, it becomes more of a system benchmark because you're not just changing the CPU, but you're potentially changing the memory. So you might use, say, just your standard 16 gigabyte single rank dual channel standard timings memory. You're going to be using lower resolutions. So you might not test 4K. You might be testing more your 1080p priority, lower settings. You might be even changing the sort of games that you're looking at, which, you know, especially for lower end GPUs might be more used for, say, your esports and competitive titles, whereas people buying higher end GPUs might be more interested in playing the intense AAA single player games. So yeah, it becomes a very complicated situation. I don't think you could sort of replace that, let's remove all the bottlenecks testing with let's put all these bottlenecks in, because they're not going to tell you the same thing and they're not going to apply to everyone. So I think Linus was recently talking in the WAN show and he covered this about how that system type of benchmarking where you are reintroducing bottlenecks, testing on lower end CPUs, it kind of becomes like special content or sort of additional content to the standard way of testing, not a replacement. It doesn't, I don't think it even makes sense. Let's say we've got an RTX 3050 coming out, sort of your $200 GPU. I don't think it makes sense to do the primary testing in that way with the system bottlenecks and all that sort of thing. But it does make sense to go back maybe in a second video or later content and do that sort of benchmarking, especially because it would take a lot of time to benchmark. So you kind of want to, you know, split these things up so it makes a lot of sense from an investment perspective. But I think that's kind of the way that potentially GPU testing is going to go, depending on the reviewer, of course. Some people are not going to invest the time to do that. But yeah, I don't have any issues with the way that stuff has been tested. And that's probably the way I'd think about going about it.
Yes, definitely. And like, you can go around in circles on this one. You can argue back and forth. But at the end of the day, I think it really boils down to being somewhat unrealistic and unreasonable in the expectations you have for reviewers for their day one review. I think, again, being a GPU review, it's best to be focusing on testing the GPU, especially because people do upgrade their CPUs. So you want to know what the uncapped performance is first before you start delving into these other scenarios. And you brought up a good point as well. So for that kind of testing, again, with all the testing I've done so far, as Tim mentioned, dual rank, dual channel, low latency memory, which helps, what would you say, helps extend the CPU headroom.
That's right.
So if you start using memory that increases latencies and decreases bandwidth, you'll run into that CPU bottleneck sooner. So that would actually be quite interesting to test as well. If you're doing these more realistic system comparisons, use the sweet spot value type memory, your CL16 type memory rather than CL14. As Tim said, single rank, 16 gigabyte kit, all that kind of stuff. And that will move the bar on where you run into these problems. And it'll actually, it'll hurt the GeForce GPUs more based on what we've seen so far. But anyway, that's my take on that. I don't think you should be harassing your favorite reviewers on, look what Hardware Unboxed found, you need to change your testing. I really hope no one's doing that, because I think the way reviewers are testing is the correct way and they're giving you the best information. But some follow-up content with these sort of system benchmarks, you know, that wouldn't hurt. And I think that's something we'll probably do. In fact, I'm certain it's something we'll do for those lower-end GPUs. So I think we've addressed that one. Happy with that, Tim?
Yeah, I'd pretty much say that's that topic done. Cool. It's certainly going to be interesting to see what happens from here on out in terms of system testing. But yeah, we just got to be realistic with what people can spend their time doing. And yeah, because you'd have like even testing one extra CPU combination effectively doubles the workload for testing a GPU, which is just not going to be possible in a lot of situations. So, and as well, on top of that, a lot of people can do the math themselves. Like if you know and have watched the previous video talking about how you may see a 20 to 30% performance reduction on a GeForce GPU when using a low-end CPU, you could sort of use the day one data that is tested on a less bottleneck system and apply that to your own configuration, similar to all the sorts of testing that we've done in the past, where it's not a guide about the exact performance you're getting, it's more about the margins between parts, and then you can apply all the additional things that you know to reduce performance to your own system. Like, for example, using lower memory, you might say, oh, well, I'm using single rank 16 gigabyte kits, so I need to take off 5 to 10% of the performance that I may see in some situations. So that's the sort of thing that I think will apply in a lot of conditions for these sort of reviews.
Yep. And as I said, as a standalone special content piece makes sense, but if you're pressuring your favorite reviewers into doing this, it's like, look, guys, there's only so much time in a day. You can only invest so much time in creating this content. What do you want? Do you want more hardware configurations tested and less games? Or do you want us to focus on trying to include as many games as possible? We've got a finite amount of time. We've got to work out what we want to include there. And you want to include extra features like looking at a bit of DLSS if it supports it, ray tracing, resizable bar, overclocking, all the other stuff in there as well. So there's a lot of stuff that goes into producing these reviews, and asking your reviewer to do all of that but just double it, pretty unreasonable. But if they can invest the time later on into looking into this stuff, well, that would be ideal. And I guess that leads fairly well into the next commonly asked question or concern we've seen in the comments, and that's sort of why has this not been shown before? I saw a lot of that. Like a lot of people were shocked, quite startled by the results, because as I said again, like seeing situations where a Ryzen 5 1600X is actually faster with a low-end Radeon GPU than it is an insanely high-end GeForce GPU, quite shocking stuff. So a lot of people were, I guess some of them were questioning the results, being like, this is too wild. Why haven't we seen this from, our other favorite reviewers? And why are you the first person to discover this? So first of all, not the first person to discover this. It's been known throughout the gaming community for quite a while that depending on the API used and the game and how much CPU load there is, one approach, let's say AMD's approach could be better or Nvidia's approach could be better. So that's been known through the sort of enthusiast gaming community, and other reviewers have talked about it and even shown these issues in the past to varying degrees. So we've even looked into it as far as like 5 years or more. I can't even remember how far back it goes, but we've looked into it in the past. But I guess us and others haven't shown it as clearly as I managed to in this latest video. And partly the reason for that is because we haven't really had the required hardware to dig in and show what's going on under, I think, more realistic test conditions. And I think that's really been the key. So in the past, we've had to use like really low resolutions, like 720p with really low quality settings, which people just dismiss those results straight away because they're like, well, I'm never playing with low quality presets at 720p, so this data means nothing to me. And when you get to more realistic resolutions and quality settings, the issue's not there. So it's kind of a non-issue. And a lot of people were saying that even about our results, but really that wasn't true because we were finding at 1080p with medium quality settings. If you want to achieve over 100 FPS, the Radeon GPUs allowed you to do that, whereas in a lot of instances, the GeForce GPUs didn't. So I guess why it hasn't been shown before are a couple of reasons. We haven't necessarily had the hardware, which is a high-end Radeon GPU. And the other reason is it's just a stupid amount of work. Like, to show it clearly so people can, first of all, understand it and you can understand what's going on. Like, it's not, oh, I'm running into a VRAM limitation there, or I'm running into some other limitation, what's going on there. To really show it clearly, you have to do what I did, was test like 4 different Radeon GPUs, 4 different GeForce GPUs, like, 4 or 5 different CPUs, and then test, it really only took 2 games to illustrate, though we had at the time seen it in more than half a dozen games, but then you needed to test different resolutions and different quality settings. And again, it was really emphasized with the medium quality preset. And a lot of reviewers would just stick it on Ultra, test the CPUs, test the GPUs, not see too much of a difference there and go. But the CPU and GPU scaling benchmarks that we do aren't done by many reviewers. So that's why we ran into it recently. So it's just, a lot of work, and we haven't always had the hardware required to do it. So I think that's why it sort of hasn't popped up till now, at least where it's like very obvious.
And I think
but
as
it
well,
has been a thing.
I think as well, as reviews go over the years, reviewers are not, sticking with an old Core i7 7700K for testing modern RTX 3090 GPUs, where you're more likely to run into the issue. People who benchmark these things are constantly upgrading the CPU as well. So if you're continually adding additional CPU headroom every generation as GPUs get faster, you're sort of moving the buffer higher and higher, so you're getting further away from the situation, or at least maintaining a reasonable gap from the situation where you'd ever see that issue, even at testing at something like 1080p. So that has a big impact as well. Reviewers aren't sitting here testing old CPUs or testing lower end CPUs when they're removing all the bottlenecks like we talked about earlier. So that's going to make it much less likely that a reviewer will see this issue in sort of your standard GPU benchmarking conditions, where you're more likely to be testing GeForce versus Radeon. Because with CPU testing, for example, this could have been more obvious if people were testing, say, 2 GPUs with their CPU testing, but at the same time, that's adding more work. People aren't going to repeat their CPU testing on a high-end GeForce GPU with a high-end AMD GPU, and high-end AMD GPUs haven't really existed before, at least in this class for a while. So, I think that impacts us quite a bit as well.
Actually, I'm glad you brought that up, because that's another point that, I actually forgot to mention, and that is, it comes back to the first question, which is why this one led on so well from that, is that when someone is testing GPU performance, they use a flagship CPU. So you don't see it there, as you said. And then when you're testing CPUs, you use a flagship GPU to test the difference in CPUs. So it really will only come up when you do the CPU, GPU scaling videos that we're known to do from time to time. So I'm glad we got around to doing that, because with how powerful GPUs have become, and then how demanding games have become on the CPU, really does highlight. And I guess that's another reason why it's been more obvious to detect now, whereas previously when we used to test, games weren't really multi-threaded, and that's why Nvidia took the approach that they took. So anyway, for a whole host of reasons, it is much easier to spot and show this now than it was many years ago.
I have a question for you that I'm really interested to hear your answer. I'm not sure whether you put this in your little notes. But when testing CPUs, so for future CPU reviews, let's say the upcoming 11th gen or Ryzen, like Zen 4, for example, would you now consider switching from using an RTX 3090 to using the 6900 XT, knowing that you're not going to get as much of a CPU limitation based on the GPU? So you've sort of got more headroom. It's going to be less bottleneck using the Radeon part. Is that something that you're considering?
There's no good answer to that one, apart from, I'm going to use both. I'm going to double my workload and use both, because that would be the ideal, optimal answer to that one. Since I've invested a ridiculous amount of time testing a whole heap of CPUs with the RTX 3090, that's what I will continue to do. But I see where you're coming from. For the lower end CPUs, where you're showing them running into problems, if you ran a Radeon GPU, you'd have that 20% extra headroom where that game may now be playable, and you may even have a bit of CPU headroom to spare. So a bit of a tough one. But
that's
again,
sort of a second video idea is probably coming along here, like test the CPU first on the 3090 based on the data you've already had, and then switch over to the 6900 XT for a second content piece, which more content for the channel is never a bad thing, is it? Probably a good time to move into the next section, which is talking about potentially where we see these issues. Because this is something that I've seen a fair bit of, especially even Linus talking about it in his WAN show segment, is the common thing I've seen is like, you're not going to pair RTX 3090 with a Core i3 processor, which is 100% fair. Most people are not going to do that. But at the same time, that's not just the only situation where this becomes an issue. And I think we'll see in upcoming content as well that this will become an issue, for example, switching from, say, 5600 XT to RTX 2060-like performance. Or the common situation as well we hear from our viewers is people not upgrading their CPU and GPU at the same time. So, for example, someone might have the budget today to buy an RTX 3070. Good on you for having thousands of dollars, but might have the ability to do that. But they're still using a Ryzen 5 2600 processor with the view that that's the next part that they may upgrade to, say, a 5600X or whatever CPU is best for them. So you're running into many different situations where this could potentially be a problem. So yeah, do you just want to elaborate a bit on that, where you've sort of seen this issue coming for other configurations?
Okay, well, there's two parts to that, I suppose. It's like, first of all, where are you going to see it? And that comes down to the sort of CPU limited, high CPU utilization type thing, which I suppose I'll get into in a moment. As for the hardware configurations, again, that's why I guess Linus didn't quite get what we were showing to a degree. Like, I think he did a good job on the WAN show, and the WAN show's live, so it's hard to nail all that stuff. I mean, we're essentially doing this discussion live, and it's very hard without having thought through everything first and scripted it out. It's a much clearer and easier and more efficient way of delivering, especially for myself. But anyway, one of the shortcomings there is hardware configurations that you can test. Like, already, as I said, it was like a good part of a 2-week process to get all that data together and present it in the video. If I could have invested another 2 weeks, I would have tested more GPUs, possibly more CPUs, and it would have made it even clearer. But I thought we had enough information there to really paint a pretty clear picture of what was going on. But, adding like a low-end GeForce GPU would have been good, like RTX 2060, for example. And I went back and did that. I made a Twitter post, and it really showed that, well, basically, if a 5600 XT, which I showed in that video, can beat an RTX 3090, I sort of left it for people to work out that an RTX 2060 would also get beaten by the 5600 XT, whereas it may have been reversed without the CPU bottleneck in a given situation. But obviously, if I had more time to test a whole heap more GPU configurations, that would have been crystal clear. So that was sort of a shortcoming there, but you're always going to run into that. Like, there's always going to be something that, I wish I had tested that, or it would have been good to include that. And it's like, yeah, well, it would have been, but if you keep, you can go on indefinitely, basically, because there's always going to be an extra game that could be tested, or a different quality setting, or a different resolution, or so. That's kind of that on the hardware configuration thing. So I guess we should probably show a video that I also put on Twitter that was brought to my attention. So it was a user, I think it was back in 2019, had upgraded from a Radeon R9 390 to I think it was a GeForce GTX 1660 Ti. Yep. Got some notes down here. Anyway, he basically upgraded to what should be a much faster GPU. The 1660 Ti should be much faster than an R9 390. I think a 1660 Ti is like, what's that, like GTX 1070 type performance? But what this user found was, when using a Core i7 3770K, so what's that, Ivy Bridge Core i7 processor, with low quality settings, so you shouldn't be GPU limited, DirectX 11, so not a low-level API, DirectX 11 in Battlefield 5, he found when upgrading to the new GeForce GPU, he was actually losing like 20-30%, even more performance in some instances. Of course, he was playing like 64-player Battlefield 5, so it wasn't a direct apples-to-apples comparison. He was pretty close too, but it was very clear that the Radeon GPU with his Core i7 processor was much faster. And he also showed the clock speeds of the GPUs, the GPU usage, and more crucially, the CPU usage. And it was very clear that his Core i7 processor was being used much more heavily with the GeForce GPU, at least 20% more utilization. It was basically, the Core i7 processor was maxed out, 100% load with the GeForce GPU, but only around 80% with the Radeon GPU, which led to higher performance and smoother frame rates. And this guy couldn't work out why his new GPU was making his computer slower, and he thought there was some kind of problem, and it turns out that's exactly what we're talking about here. So I guess getting back to your question, Tim, it doesn't have to be an RTX 3090. It can be a comparison between an R9 390 and a GTX 1660 Ti. The key ingredient is maximum CPU utilization. So a term I often used in that video was CPU limited testing. You often hear it as a CPU bottleneck or CPU bound. The thing is with that terminology, it can mean different things. And I guess this is where a lot of confusion comes from, because when we do CPU gaming benchmarks, we use games that heavily utilize the CPU and max it out. But then people will come to us and be like, why didn't you use Roller Coaster Tycoon? That's very CPU intensive. Or why didn't you use StarCraft 2? That's very CPU intensive. It's always, it's limited by the CPU. It's never limited by the GPU, that type of game. Microsoft Flight Simulator 2020 is even another example of a much more recent game. Why don't you use those games for testing CPU performance? And the answer is you're really testing single-threaded CPU performance. Microsoft Flight Simulator is a little bit better than that, but it's still not much better. And so you're often bound by that primary thread. So while you are CPU limited, you're not fully utilizing your CPU. So one core will be maxed out, the next one may be doing a bit of work, and then say it's like a 6-core processor, you'll have 3 or so cores doing very little work, not being utilized anywhere near their maximum potential. So that's one form of CPU limited gaming. And then the other form of CPU limited gaming is when you're at 100% utilization, which is what this guy with the Core i7-3770K was looking at. Now, the problem with the GeForce GPUs with this driver overhead, or just, the overhead in general, when the CPU isn't 100% utilized, it's not going to be a problem. So where the GeForce GPUs become much slower than the Radeon GPUs is when the CPU is fully utilized. So not just CPU limited, like what you'd see in the games I spoke of, Microsoft Flight Simulator, Roller Coaster Tycoon, StarCraft, for example. It has to be a game like Cyberpunk 2077, or what we see in Watch Dogs Legion, Horizon Zero Dawn, those kind of games that actually fully utilize all cores and max them out with a Radeon GPU. Because with the GeForce GPU, because the Radeon GPU affords you on a quad core, about 20% more headroom. So I hope that wasn't a whole heap of waffle and it was relatively easy to follow, but it's about, being fully utilized across all cores.
Yeah, so I think it's really important to note there that these are realistic situations that people can run into. Of course, it is going to depend heavily on the exact situation that a user wants to play at, because, for example, if that person with his GTX 1660 Ti decided to play at 1440p ultra settings instead of playing at 1080p low settings in Battlefield 5, then he's going to be less likely to have run into that problem. Whether or not he will run into that problem in that exact game, we're not sure because we haven't tested it. But again, This is sort of it's a fine balancing act. You can't just look at someone's system and the games that they play and say, you're 100% going to run into this issue. It's going to be, well, maybe you'll see that, let's say you're playing with, say, an RTX 3070, maybe you'll see it with that GPU, but if you were using a 2060, then maybe you won't see it on a given CPU configuration. But then if you go a couple of tiers lower in the CPU, then you're going to shift the whole situation again in terms of the GPUs that are going to run into the issue with that configuration. So it's a really difficult problem to just say, yes, this is an issue, no, this isn't an issue for a range of people, because it's so configuration and game specific. And not only that, the sort of things you want to do with your system is going to have an influence as well, because I'm not as interested in playing Battlefield at 1080p low settings. I'd be more inclined to personally play it at 1440p ultra settings. So this is going to change a lot of the conversation around this. But we have seen many people talking about how they have run into this on their configuration, and it's usually going to be, as the video that we were just showing, for example, a Core i7 processor from several generations ago, particularly when the quad cores were sort of the flagship that you could get at the time. You're much more likely to see it with mid-range GPUs. And I think that tends to be the common upgrade that people are doing, where, again, we've sort of over the years talked about how things like a Core i7 7700K, for example, is still pretty good for gaming in a lot of configurations. But then you realize that over time, especially upgrading to just your sort of mid-range $200, $300 GPUs, it may not be quite as good with the GeForce products. So yeah, it's certainly an interesting thing that will require a lot more, even just user-specific reports to figure out where sort of that knife's edge lies with performance and bottlenecking in this way. Mm-hmm.
Yeah, and you brought up a good point with all of that, the resolution and stuff. I suspect this guy didn't want to play it low. He was probably aiming for more medium quality type settings, but he was trying to show that, look, when I completely remove what should be a GPU bottleneck, it still doesn't make sense.
Yep.
So, but even if he was using medium quality settings, you'd see the same sort of thing. And by going to 1440p Ultra, like what you spoke of, that's not really an option with this hardware. So while you'd play at that, he would be looking at like 30 FPS or something, or 40 FPS. And clearly he wasn't interested in even 60 FPS. This guy, I suspect, had probably a high refresh rate monitor, wanted 120, 140 FPS. So he was trying to work out what settings he needs to achieve that. And he was going backwards with his GPU upgrade, which would have been very confusing. And I guess something else we should probably mention is the fact that we're certainly not saying don't buy a GeForce GPU. Like, we're trying to help explain to people like the guy with the Core i7 3770K why it was that he was seeing what he was seeing. We're not saying don't buy a GeForce GPU. Just be aware that this can be a problem, especially if you have a lower end CPU. So if you have a low end CPU and you don't want to upgrade it, and you know that a higher end GPU can still offer you more performance, it's probably best in that situation to get a Radeon GPU, because it will give you 20% more CPU performance than you would have had otherwise. And that's quite, 20% is quite significant. Like, some people would upgrade their CPU for 20% more gaming performance. So it's not, an insignificant amount of performance that we're talking about here. But if you're, just say, for example, the RX 6800 XT was much worse value than the RTX 3080, and you're like, oh, the RTX 3080, that's the GPU to get. It's very clear that's the product to buy, but I'm worried about this overhead issue because my CPU is not quite where it should be. I would still recommend getting the 3080 in that hypothetical situation, and just aim to upgrade your CPU as your next upgrade. Because I guess it is important to note that in my Watch Dogs Legion and my Horizon Zero Dawn benchmarks, it was certainly not a situation where the GeForce GPU was sending you into unplayable territory. We were talking about dipping down from 100 FPS to like 80, which certainly isn't ideal from a GPU upgrade, but it's not crippling the system where you're getting unplayable performance. So it just means when you do finally upgrade your CPU, you're going to get a very big performance upgrade.
Yeah, I think it's just another talking point that can be used when discussing in those situations where performance and value is very close, like what we're often seeing in the GPU market right now, excluding pricing issues, obviously. It just becomes another talking point, like ray tracing, like DLSS, and like NVIDIA's encoder on the NVIDIA side. On AMD's side, we've had things like extra VRAM with this generation, and now we sort of get this other talking point that can be used to sort of separate two GPUs depending on the configuration. So again, it might be in a review where we're talking about maybe not a 3080, but let's say like an upcoming 6700 XT or something like that. It may become a situation where if the two GPUs are very close, then for your higher end CPU buyers, you may swing more towards GeForce because of features like DLSS, ray tracing, and that sort of thing. But if you're using a lower end CPU, then it might be the opposite, where it makes more sense for you to buy the Radeon GPU because of things like the CPU limitation on lower end hardware. So yeah, it's just another interesting talking point, and certainly doesn't apply to everyone, particularly people with high end CPUs. So yeah, it's just going to make your conclusions even longer than they are these days, considering all these individual features and considerations to talk about when comparing GPUs. It certainly is much more complicated than in previous years. So
definitely, just what we need, longer reviews. And I guess one of the last things we'll talk about just quickly, because I think we've been going for almost an hour at this point, so it's going to be another one of those hour-long videos, is... why is it? Because we've seen a lot of people comment, oh, gee, I can't believe the Nvidia driver is so bad. I thought it was AMD that had the bad drivers. Why is the Nvidia driver so bad? And the answer is, well, it's not bad. And in a lot of ways, the way Nvidia has gone about doing things was genius. It was really impressive what they did with their driver for DirectX 11 games. But the problem is it's created an overhead now in DirectX 12 games where the trickery they did with their driver is no longer necessary. And basically, their driver was more efficient for DirectX 11 games as long as the CPU wasn't maxed out. Which, going back 3 years, just 3 years, games really didn't often max out a 4-core 8-thread processor. Like, when Ryzen hit the scene, the 7700K was the flagship gaming CPU. That was the bee's knees, the best gaming CPU you could get without going into, the extreme high-end desktop stuff. So back then, games weren't particularly CPU demanding. They were mostly single-threaded. Occasionally, they would use, 2 cores. And the reason for that was most people had dual-core processors. Like, think Pentium G4560 had great value. Was that like a $70 US CPU back in the day? Yep. A lot of people had dual cores, so making games, require or heavily use 4 cores wasn't a thing, and you could blame Intel for that, but we won't get into that. That was the situation. So what Nvidia did was they took the scheduler off the die, the silicon, with, I think it was Fermi was the last time they had the hardware scheduler, and with Kepler, to make it more power efficient, they moved that for a thing for the CPU to handle. So the scheduler became software side rather than hardware side, and they basically were splitting up the draw calls from the primary thread and spreading that across, at the time, say a quad core, across the other 3 cores, and that was helping eliminate what would you call it, the single thread bottleneck by spreading it more evenly. So that was very cool, and that was something that the Radeon GPUs didn't do. So the game had to be really optimized for the Radeon GPUs, or the DirectX 11 performance when CPU limited was quite awful. But then now...
Yeah, and I think I'll just interject there, but that is why that exact situation you were just talking about is why there has been the perception of AMD having higher CPU overhead with their drivers previously with DirectX 11 tiles, is again because Nvidia was able to split up the draw cores or the processing that needed to be done across multiple CPU cores, reduces the CPU bottleneck. AMD wasn't doing that, so it had a higher CPU performance, limited by the single thread nature of those games at the time. So continue.
Yes. So that's right. So I guess to add to that, so even then, Nvidia still had higher driver overhead for the CPU. They were just using more of the CPU. Well, they were just using more of the CPU. Yep. Instead of being limited by 100% utilization on one thread, they were spreading it across all the threads, which was increasing the overall utilization of the CPU, whereas the Radeon GPUs were still limited by the single thread. Yep. So they were using less of the CPU, so they weren't utilizing the CPU as well.
Yep.
But then that's been flipped on its head now that games are much more CPU intensive. Games using low-level APIs like Vulkan and DirectX 12 now spread the load across multiple cores. And so when you get an older CPU that's starting to be maxed out, that extra overhead that NVIDIA did to actually try and use more of the CPU is now redundant, but they're still doing it. So
they have to, because the scheduler has been moved off the hardware. I think that's right. One of the interesting things that I find about this whole situation is that while it may be more efficient to do it that way, and I'm sure that was part of NVIDIA's thinking back in the day, we need to make our GPUs more efficient. We've just had the hottest, loudest GPUs at the time. Don't want that reputation anymore. Let's optimize it. But AMD has got a different set of priorities in mind with their GPUs. It's not necessarily about the efficiency of their products. They are also designing these GPU cores to be used in consoles. And as we've seen over the past 7 years up until very recently, the consoles had a horribly inadequate CPU. So when you're using an 8-core Jaguar CPU, you cannot have a situation where you're trying to increase driver overhead to run some hardware or run some scheduling on the CPU, because the games need all that CPU power just to run the game. So you can't add on an extra 20% to a console to do a whole bunch of stuff that the GPU needs to do. So it had to be a hardware scheduler for their design. At least that's my thinking, and I would assume that if you talk to AMD engineers, they'll probably tell you that's why they've kept the hardware schedule for this long. It just wouldn't have been a viable solution for the product that they were designing it for. And that probably had implications for having their designs be less efficient, because it has to do more on the GPU side. But again, just different priorities for each company. And what you said before about it being sort of a genius solution at the time, it really was a very, very clever solution that AMD, I'm sure they've put some work onto trying to figure out how this was done. But in that time, they had never implemented that solution on their products. So for NVIDIA at the time, it did make a lot of sense. And it just so happens today, games are different. So the benefit that they had previously is no longer a benefit. It's a weakness for them in those situations. So
at least, when CPU limited.
Yep.
And again, while it did make their DirectX 11 performance it improved their DirectX performance significantly. Again, it did that because games didn't use much of the CPU. But now that you have games that, whether using the DirectX 11 mode or the DirectX 12 mode, use a lot of the CPU, like Battlefield 5 DirectX 11, Watch Dogs Legion DirectX 11, those kind of games still use a lot of the CPU. And you're running into this problem with the GeForce GPUs, even in DirectX 11, because all the threads are now maxed out. So anyway, that's the situation there.
So I think based on that discussion, you're probably getting an idea of whether Nvidia can actually resolve this problem on their current generation GPU architectures. Because this is the thing that we're seeing a lot in the comments is, oh, you've brought this to light. Hopefully Nvidia is going to be able to fix it. But our understanding of these GPU architectures is that when Nvidia is using a software scheduler and AMD is using a hardware scheduler, Nvidia can't just add a hardware scheduler into a design that already exists. So when you've got this situation where they have to do some of the scheduling on the software side, on the CPU side, it's not really a fixable problem to any significant degree. They may be able to optimize their software scheduler to some amount so that maybe instead of using 20%, using 10% or whatever the situation is, but they're never going to get to a situation where they're able to offload all of it onto the hardware because they have deliberately designed the architecture in this way. Of course, maybe there is a situation, I'm not going to rule it out, that they can do some GPU trickery and offload the entire thing to some other part of the GPU. I don't know if that's possible. I'm not a GPU architecture. A lot of NVIDIA's architectural designs are very closed off, so you don't really know what's going on. But it is a fundamental difference in the hardware. So potentially down the line, let's say a couple of generations, they might move back to using a hardware scheduler. But right now, it doesn't seem like something that is fully resolvable, at least in the way that people would be hoping for, where they just remove all the overhead. Let's just put that back on the GPU. It doesn't seem like that's something that can actually be done. So,
Yep, I agree with all of that. And I think if they could optimize, say, the Watch Dogs Legion performance that we showed, that becomes a big issue for them because people are now aware of it and people are pointing it out. They go back and manage somehow to optimize that and get the margin down significantly. That would be a per game optimization, so it's not going to solve it for all games. So, and that's been a problem for, again, AMD in the past with Radeon GPUs. So where it was optimized and it ran quite well on AMD GPUs, like Rainbow Six Siege, for example, DirectX 11, there's no real bottleneck there with the Radeon GPUs when the CPU is heavily utilized because it's been heavily optimized for. But when it's not, it's a bit of a mess. And the problem is, a lot of the optimization, as you might imagine, takes place on games that reviewers are testing with, but other games that are still maybe very popular but don't get benchmarked with, there's not as much optimization there, unless the gamers kick up a bit of a stink there and make it known to the company that they know there's optimization work that could be done there. But anyway, so I reckon we've probably gone just about long enough on this one.
I agree.
I'm sure we can get back and do it again once the second video is up, because that has even more information, more benchmarks, a few eye-opening things there as well, and I'll be testing even more realistic hardware configurations, let's say. So lower-end CPUs, lower-end GPUs. So it should be quite interesting.
All right, so I think that just about wraps up this little discussion video talking about the NVIDIA driver overhead problem. I've been really enjoying doing these discussion videos, and I think that a lot of you guys have been appreciating them as well. I do understand this video is, again, probably going to be like an hour long, but hopefully people that have watched it to the end have really got some stuff out of it, because with these videos that are sort of more for the general audience that are going to be spread on places like Reddit, talked about in other places, we don't want to make them an hour long with a whole bunch of additional explanations going into how the drivers work and all that sort of thing, which is why we linked, for example, that, what was it, that guy's name that he made a great video about the driver overhead situation?
Nerd Tech. Yep.
Yeah.
Nerd Tech. Shout out to him.
Yeah. A lot of the information that we sort of talked about in here comes from that video, which is a great compliment to that original video, but you don't want to spend 10 minutes talking about all that sort of stuff in that video. So,
well, again, we can link that video below this one again for anyone that didn't see it in the previous video. So, check that video out. It explains all of this stuff really clearly. It's a very well-made video. Yeah.
So, I think these discussion videos become a good complement for people that sort of want more information on stuff that's been tested. So you get your hour-long fix, you can put it on the background as a podcast or something like that, and hopefully you've been enjoying it. So, if you're interested in more of these pieces. We're probably going to do more of them, so you can always subscribe to the channel and support us in places like Patreon and Floatplane, where you'll be able to chat to us in Discord, where we're constantly talking about these things, and behind-the-scenes videos, monthly live streams, which will be happening probably in 1 or 2 weeks, so it's definitely a good time to sign up to those. And
On that note, if there's any other questions that you'd like answered that around this topic, you can certainly ask them for the Q&A series.
yeah, exactly. So we'll be doing that in addition to sort of these discussion pieces, which is always a bit of fun as well. So yeah, I think that's pretty much it for this one, unless you've got anything else to add.
No, as you were just saying, Floatplane, Patreon, if you want to support the channel directly, get access to cool perks. Again, we got monthly live stream where Tim and myself get together similar to this and chat about whatever you guys want us to chat about. Behind the scenes content, Q&As, really cool Discord server. So for Hardware Unboxed members, anyway, all that cool stuff. So if you're interested, check that out. But if not, that's also cool. And yeah, that's pretty much it for this one. So thank you very much for watching. I'm your host, Steve.
I'm your host, Tim. See you
next time.
Next one.
Next time.